Let's do a few more. So here we're working on integration. Got functions that are transcendental. So question number 18, that one's kind of interesting. I look at my inside function here, and I think a little bit about that one. And this one's a little harder to see where this x plus 1 came from until after I do the derivative. If I did the derivative of that, wouldn't it be 2x plus 2 with respect to x if I write it in differential form? And I don't have the 2x plus 2. I have the x plus 1. But notice if I factor out a 2, I see that x plus 1, and that x plus 1 dx, this x plus 1 dx, I want to know what I can replace that x plus 1 dx with. So that tells me maybe it would be good to get rid of that constant 2 out in front. So I can do that by multiplying by a half on both sides. Then that allows me to come make a substitution. In place of the exponent, I can use a u, and then see that x plus 1 together with that dx right here? That's the same as 1/2 du. Let me put the du there and the 1/2 in front. Okay, it's all times, so it doesn't matter where I put it. So when I integrate this, the 1/2 just gets carried along. E to the u comes from e to the u, and then I need that plus c. And then in place of the u, I can put the x squared plus 2x. I need the 1/2 out in front. Make that look better. Need the little plus c at the end, and there's my answer. And don't forget, you can always do the derivative and make sure that it works. Okay. Now we still do not know how to integrate trig functions unless what we're trying to integrate looks like the answer to a derivative problem from section 3.2. So like secant tangent, we know that's the derivative of secant. Okay? So on this one, I'm going to let the u be 2 minus x. du would equal -1 dx. But I'm trying to replace dx, so I'm going to divide by or multiply by a -1 to get the dx by itself. Then I'm going to make a substitution, and in place of the 2 minus x, I'm going to put a u in both places, and in place of this dx right here, I can put a negative du, but let's put the negative in front and the du at the end, so everything's in its normal place. Then didn't secant u, tangent u come from secant u? But I need to bring the constant along. Need to throw a plus c on there. And I need to get the x's back in. So I'm going to replace the u. The u was equal to 2 minus x. So I'm going to put the 2 minus x back in with a plus c. And that's it. Okay. All right, let's take a look at just a few more. Let's look at number 20. Perfect. See the tan x for my inside function? Notice the derivative of that would be secant squared. And really, I'm doing that whole du dx equals secant squared, and then I'm just going to write it in differential form. Sometimes we just can skip that middle step and go right to the differential form. So you see that secant squared x dx, I want to replace that with a du. And then I'm going to take this tangent x, which is under the radical, and replace it with u, and rewrite that as u to the 1/3. Haven't integrated yet. I've just done the substitution piece, but now it's ready to go. If I added 1 to 1/3, I'd get 4/3. So I'd need a 3/4 to make that cancel out in front. Throw a plus c on there. That's basically it, except for you can't leave it with u's. So you're going to go and put the tangent x back in. So you get back to x's. And it had radicals to start with, so you need to get back to radicals. You can keep the 3/4 completely in front. Do your radical, which is a cube root of the tan x to the 4th power. Okay, or you can put the 3 with the tan x, cube root of tan x to the 4th on top over 4 and do the plus c. I'm only telling you about that in case you go to the back of the book and your answer is different. You might be perfectly right. You just need to know how to manipulate it. All right, now as I'm looking at this one, I'm thinking about that cosine x as being cubed, and the derivative of cosine might be where that sine came from. So I'm going to rewrite this one as a cosine to the -3. Let's write it with cosine of x to the -3 with that sine x dx off to the side. So I just brought the cosine x to the 3rd power back up. That's why it's negative now. So I'm going to let u be the cosine x. Then du would equal a sine x, but I have to think about whether I need a negative or not. No, I wouldn't, right? I would not. Because the derivative of sine would be cosine, and that's what I want it to be. But I need to have it in differential form so I can see that this is going to get replaced with du. This is replaced with u, and I just need to integrate that. So that's going to be a u. Add 1 would be -2. So you need a -1/2 out in front. Put a plus c on it. Get it back into having x's, so replace the u with cosine x, and get rid of the negative exponent. So it would move back down here, be a +2, so I can put it down in the denominator along with the 2. All right, now I'm worried that I lost something because I feel as though I've got a -1/2, and I feel like I messed up on my negative earlier. What did I miss? Oh, I missed something. Okay, listen to me on this. It's easy to do this, so I don't mind that I made the mistake, but you have to hear where I made my mistake. Right in here, when I went from here to here, I have to be in derivative mode. All right, so I'm not going to redo the video. I want you just to see that this is an issue. It's easy to make this mistake. I was in derivative mode. The cosine of x is really negative, and I don't want the negative, so I need to divide by it on both sides. Then what's going in place of this right here really was a negative du. Let me put the negative there. Let me carry it along here. So that really turns out to be a positive. Really needs to be, let me put it right on top of it, needs to be a positive. So this really would have been a +1. All right, it's easy to do that, especially if you're tired, but it's also easy to catch it. I usually check my work like right there. I just kind of go and I mentally start doing the derivative, and I realized, hey, wait a minute, something's off with my signs. So I was able to go back and fix it. Okay. Also, I wanted to do one definite integral that involved a transcendental function. So let's do this one. Okay. So here, we first are going to integrate, then we'll go ahead and deal with evaluating it and getting that number that represents the net area. All right, so I do have an inside function. I can use u substitution. It would be equal, du would be equal to -1 dx. I'm trying to replace dx. So I'm going to move that -1 out of the way. Multiplying or dividing by -1 gets rid of it. And then I'm going to start getting my u's in there. So I can put the u up there as the exponent, and then I can also replace dx with -1 du. I'm going to write the du there, but put the negative there. Now I'm still needing to integrate, but I have u's, so those limits of integration could be changed to be in terms of u at this point, or you could keep them as placeholders and get back to x's, and then get back to plugging in the 1 and the 2. Either way, I'm going to do it by keeping the placeholders there for a moment. So if I'm integrating that, then I know that's going to wind up being just a negative e to the u when I integrate. I'm going to have to evaluate it from here to here, but it won't be from 1 to 2. I could figure out what it is, or I could just wait until I get that x back in. Then once the x's are back in, I can put the 1 and the 2 in there. So now I'm going to plug in the top number, then see what happens when I plug in the bottom number. This minus is the formula. The other two negatives are coming from me having a negative there. All right, so this is e to the -1 minus negative e to the 0. That's e to the -1 plus e to the 0. And e to the 0, isn't that 1? Any number to the 0 power? Now let's see, did I lose? I lost this guy, so let me make sure I carry him along. He's still there. So I wind up with a negative 1 over e plus 1. You might see that written. They might wind up writing that with e over e, so they can put it all, they can rewrite it as one rational function, but this would be widely accepted, and that would be okay too. If you're ever wondering if they're the same, you're just trying to check it, you could use a decimal, plug it in, see what the decimal is, and see if it's equivalent to the other. All right, now one more time, I want to show you how to change to use if you decide you want to do that. Change these limits right here to use. It's kind of fun. Okay. Trying to... All right, so you know how we let u equal 1 minus x? So we have u equals 1 minus x. So if x equals 2, then u would equal 1 minus 2. And if x equaled 1, the bottom limit, then u would equal 1 minus 1, which is 0. So what would happen is right here, I could have changed it to having a 0 at the bottom and a -1 at the top, and do this integration. Okay. So e to the u would be e to the u, still be negative, evaluate it from 0 to -1, and now I never go back to x's. I just plug in the -1 for u and then subtract a negative e to the 0, and there you get your -1 over e, and here's your plus 1. So that side is if you want to change to use, and then the advantage would be that you don't have to do this part down here. This wouldn't need to be done. Okay. Well, it is being done. It's just being done separately right there. Okay. So you can decide how you want to approach it. Whatever clicks more for you would be fine.